Like you said, my name is Jennifer Hadley. I'm from the University of Saskatchewan. If you don't know where we are, Saskatchewan's the one in the middle of Canada. You can draw it while drunk, but you can't spell it. So along with being a Linux sysadmin, I also help support storage and backups for high-performance computing consortium across Canada. In the past, I've been part of the team supporting our VMware infrastructure and private cloud. Lately, my job focus has shifted towards automation and monitoring. Far more interesting stuff, in my opinion. Today, I'm going to talk a little bit about our journey in the past couple years as we have attempted to shift from handcrafting artisanal servers to moving towards a more self-service model. So in the next 30 minutes, I'll go over what our environment is like and what makes it so challenging and interesting to work in, how and why we implemented Puppet, some lessons we learned along the way, and where we're going to go from here, because we always have plans. We're never done. This talk is probably a lot more interesting to those of you who are just getting started. If you've been using Puppet for quite a while, or longer than I have, you get to shake your head at some of our mistakes. So a little bit about the University of Saskatchewan, so you can get an idea of what we're like. We have approximately 20,000 students and 5,500 full-time faculty and staff. We're classified as a medical legal university with a strong research focus. We have 14 colleges, including an Edwards School of Business, Engineering, Agriculture, and Vet Med. We also host a Canadian light source, a synchrotron, and the Vaccine and Infectious Diseases Organization facility. So, I work for Infrastructure Services, a group within Information and Communication Technology. It's responsible for the central infrastructure on campus. We support researchers, students, staff, and faculty, both on our main campus and the satellite campuses around the province. This is just a small list of our service catalog right now. There are over 40 different services covering everything from point-of-sale terminals in the computer store to Blackboard, our e-educational platform. Each of these service groups will have multiple applications and services that they manage and have ownership of. These services are built using a wide variety of applications, some of which have been developed using open source components on campus, some of which are purchased products, all of which need to be configured for each group. We have over 1,600 VMs in our VMware environment, mostly built with different versions of Windows and Red Hat. But we also manage some Debian, Ubuntu, and a Solaris environment, because we can never get rid of Solaris. Stuck for life. When I was writing this, I looked through our application catalog to come up with some of these examples and found that there was over 300 listed that we are currently expected to support. We have a reasonably sized team of sysadmins, 17 with responsibilities that are split between virtualization, Windows, Unix, storage, backup. And we often take the role of application administrator as well, even though we've tried pushing some of this back on service owners. We have different levels of experience and knowledge on these apps, and there's often only one person who's the expert. In the past couple of years, ICT has been working to absorb other IT groups on campus in an effort to improve the overall services being delivered. You know that application running on that Windows XP desktop under your desk? Yeah, we'll run that for you, no charge. As a result of this policy, the number of applications and servers we need to manage has grown exponentially. We aren't large compared to the Netflix of the world, but the wide variety of service groups, applications, and OSs we are dealing with is making automation really challenging. We don't have the large number of the same of anything. There's not a lot of cattle in our environment, just a really smelly dairy herd that's used for research. Before we started looking at automation, our systems were deployed either via VMware templates or kickstarted from Red Hat Satellite Server for RHEL servers. Everything else was manually installed from ISOs. Group policies and PowerShells are used by the Windows team to make mass changes over all the Windows servers. Scripts are run from the satellite server to make changes to RHEL servers. Solaris and other Unix groups are completely manual. And while we know that changes should be made in development before test, before production, nothing is really being done to ensure this. Often the configuration would drift between the environments. Why is this not working in prod? It worked in test. Oh, last week we did that change in prod, that emergency change, you know, and yeah, that's probably breaking it now. Typically, there was documentation on how the application and service was configured, but depending on who did the install, you get their idea of good. Requests for new services or applications comes in by the way of tickets, if we're lucky, because it comes with information, or a phone call from the manager if you're not. Some of the challenges we had to keep in mind as well as we start down this automation path. We work under an ITIL framework. Part of this deals with how changes should be made that affect a service. If you've never worked with change management, for us, this means that if you want to make a change to a system or application in a production environment, a request for change has to be filled out and approved by your manager. If the change is considered high risk, you may have to defend your position before a change advisory board. Some of the work we do is classified under standard changes, so we could just fill out a form, but there's still a lot of paperwork. In theory, this is supposed to reduce the service disruption. In reality, change management is increasing our workload and making automation difficult. We have a bit of problems with culture change as well. Learning new skills is hard. Replacing old processes is even harder. And we don't get the time we need and want to learn new technologies or best practices. We typically have a dev, test, and production environment, but not with all service groups, so some of them have more complicated workflows we have to work around. We often have trouble agreeing on standards and best practices, especially between the different teams. Some of the standards we have will fall under tribal knowledge and haven't even been documented. Some have been documented, but they're maybe in a location that the other team can't access or usually doesn't access, SharePoint versus Wiki. We have silos between Windows, Linux, and DBA teams, even though we're all in the same building, let alone between dev and ops. So why are we even bothering? It's really complicated. It's probably just easier to go with the flow. Well, I'm sure everybody has this story, but this is my story, so it's important to me. A new project lead was hired for a major ERP project on campus. This is an enterprise resource planning system, but for us, this means major project, high visibility, lots of money. They start off the first project meeting explaining their vision of how code should flow. This involves recreating an entire VM for each bit of the app. None of our other developers work this way. It seems like a lot of work. We had to explain to the project lead that we didn't have the manpower or the infrastructure in place to allow them to do this, and this was not a great answer. It went up the food chain and back down, and we were told to find a way to make this work. Along with this mandate to get faster at deploying services, we have other problems that crop up that we want to solve. Configuration drip. Why is SE Linux in permissive mode on the server? No standard deployments of applications. Well, if Bob built that server, the MySQL root password's probably different. Did my group policy apply, and what did it actually do? These types of problems made it harder to troubleshoot issues, increasing the time it took to resolve tickets. There's nothing more frustrating than getting a call on a Saturday afternoon from your IT director saying Shib authentication is down. Can you take a look? And now you know you're spending your Saturday afternoon reading bash history to figure out what Bob did on what was supposed to be read-only Friday, so you can reverse the change. Even in a research and education environment, downtime needs to be kept to a minimum, and minor issues can escalate to major problems fairly quickly. We decided our first step towards automation should be dealing with the configuration management problem. If we could build a server and application the same way every time, we should get faster and more responsive at delivering services. Puppet could be a solution to our problems, at least some of them. So how did we go about doing this? Well, you take the training course, they tell you put the Puppet agent on all your servers and control NTP, because this is a really easy win. We didn't do that. We felt we needed to prove Puppet could actually handle what was a relatively simple app OS install before we started tackling anything more complicated or deploying it more widely in our environment. So I replicated the work that was originally done via Kickstart, wrote Puppet code to be able to deploy a JBoss 7 application server for our identity management team on Rails 7, the OS configuration, the application install, all the fun bits. Because this was one of our first Rails 7 boxes, I was also able to add code from the SysBenchmarks security recommendations. This was a good group to pilot with because they were already using Jenkins as part of the code deployment, so they're the other half of the continuous integration cycle. But as a result of this, the stock deployment of JBoss required some specific customization for them. This little pilot was successful enough that we decided to move forward with Puppet and Rails 7s. All Rails 7 systems would have their OS and easy applications configurations Puppetized. So Apache, Tomcat, JBoss, the easy stuff. We purchased Puppet Enterprise and on-site training course for all our other Unix and Windows admins. Hopefully with the training, it would make it easier for people to get started. At the same time, we also started weekly architect meetings with some senior people to decide how we wouldn't want Puppet to work for us, and suggested to our Windows group that, hey, we have this really cool tool, you should use it too. Yeah, it turns out that's not a great idea. A Linux person advocating tools to the Windows team went over like a lead balloon. So instead, we brought a Windows team member into the group to determine if Puppet was feasible for them. We were also lucky at this time to get involved with the Puppet Ramp-Up project as part of our enterprise license. So we were able to use them quite a bit as a resource, mostly so I could ask stupid questions. We started with Puppet Enterprise 2015 and R10K, but quickly upgraded to 2016 in Code Manager as soon as we could. We're using a control repo module to control environments. This module contains the Puppet file and Hire database, with each branch in the Git repo defining an environment. So there are 3 branches: development, test, and production. We have unique Puppet files in each branch of the control repo, so we can have different modules available to each of the different environments, or more specifically, different versions of a module available in each environment. We've declared our in-house Puppet modules with the branch tag. So all the modules in the develop Puppet file reference the development Git branch in each module. What this means is when code is pushed to the Git development branch for an in-house written module, it's automatically available to the nodes in the development environment. Rather than using tags, we were kind of confused by that to start off with. So this was easier to get people on board with the project. Modules from the Forge are dealt with a little different. They're defined based on specific versions, so we can stage the upcoding of this as well. So we can test out Tomcat in development before we push it anywhere more important. We are storing our Hire database with the control repo, and we've got encrypted passwords in this Hire database. So this lets us have a different password for MySQL in dev, test, and production. Our initial code workflow that we designed by ourselves without anybody else's help, maybe not the best idea. It was designed to match how we, as system administrators, were already making changes in the majority of cases. Each module has its own repo with 3 static branches: development, test, production. I would pull the development branch, do work, push the development branch, and then merge dev into test. That's not a great idea when you start having other people work with this environment as well. So it's really obvious we're new to change control. I'm not a coder. I never used Git before I started any of this. The end result was when other people were working this, I managed to pull somebody's changes from dev and push them to tests before they were ready to go. This is obviously bad. So we talked to somebody who's an actual developer, and we came up with the feature branch type model, which I think is pretty much recommended by everybody now. I'm not sure how we missed that. A branch is cloned from production, work is done in the feature branch, and then merged into the development branch, and then the changes are pushed. Once the changes are confirmed to be working in development, they can be merged into tests and then production before destroying the feature branch. Environment branches are long-lived. Feature branch, short-lived. So learning Git along with Puppet and dealing with a complicated workflow caused problems in our environment. We don't have a lot of experience troubleshooting these weird Git problems that could crop up. So the giant wall of code here is basically a script that was written that would output all the commands that somebody required to go through this workflow. This really helped a lot of people get over the initial panic of, oh my God, what if I do something wrong? I'm going to destroy everything by pushing to the wrong branch. So they could just copy and paste what was out on the screen. And it also gave them a commit message and told them what they should do. It's just a quick little Perl thing. We're using a role and profile model, which seems to be generally accepted as best practice, but we had a hard time wrapping our minds around this at the beginning because the examples we were seeing didn't really match what we would do. We didn't have a large group of web servers that were exactly the same. So instead, we've settled on defining role as the service you are currently building, i.e. role analytics, or roles bookware. Profiles are then defined based on technology, of course, and the classes. These are the classes that we use to wrap our best practices and standards around the Forge modules. Profiles are stacked together like a Lego to build our role or our service. And the role name matches our service catalog, so it's kind of easy to track what we're doing. Anything that doesn't fit into the role or profile class can go in its own module if you're running more than one class, or go into a generic platforms module we wrote to get started with all this. People didn't really want to write modules, so they were more inclined to use something that was structured and put in place already. So we don't have a lot of modules, we haven't really grown that big. They'd rather just shove it somewhere else. Roles, profiles, control repo are all different modules. We did this because we found we were dealing with multiple people new to Git. It was just easier to avoid the possible conflicts right off. We had people so concerned that they were going to have to deal with a conflict message in Git that they scheduled their work. I'll do work on this role in the morning, and you can do yours in the afternoon. We're not software developers. We're sysadmins. We're learning. It's hard. Puppet documentation says roles should not set class parameters for any profiles. Rather, this info should come from some business data stored in Hiera. We didn't like that. We found it irritating to have to go to multiple locations to look at how this service was being built. We wanted one place to look at all the information. So we've been putting more and more information to this role. To build bookware, install Postgres on the database host using case statements, add an application account to the web host. Similar logic is used to build. Similar logic is being used in the role to differentiate between dev, test, and production systems. In development and test, add the application account to the web host and set the Postgres max connections on the database. Some of this is probably more appropriate in the application orchestrator because it's going to cut down the number of role files maybe we're going to need. But until we get more experience with this feature at Puppet Enterprise, we don't see value in switching just yet. We're using the PE console, of course, for classification, with each node being assigned two groups, an environment group and a role group. The role group is named after the one class that has been assigned to it, and the classification page, well, it's getting pretty long, but luckily I can Control F and find what I'm looking for. Our hosts are mostly named based on the service that we're creating, so rules can be used to automatically add our nodes to these environment and role groups. So we'll have like a DB, it automatically gets in the DB group. It's pretty obvious. So I mentioned change management earlier. This is what I have to deal with. Before I can make a change to a production server, I need to fill out a form with the risk, the change, and the servers that are going to be affected. Well, I can include Puppet code now and in the change request, so this reduces the amount of documentation I need to do. I don't have to write a whole new doc to say what I'm going to do. I can prove the exact change was done in dev and test first with a Git log or a report from the Puppet console. So this helps define my risk as low because, hey, I tested it. But if I'm making a change to a profile that's going to affect a wide variety of servers, how do I know what's going to be affected? I actually started using MCO to gather this information. So these are some of the MCO commands I've been finding useful. MCO Puppet run once minus W class name, list all the servers that this class is applied to. You can also use it to disable Puppet on all the nodes with a class. Somebody did something really bad. Maybe we should just not use that class for a while. Or not run Puppet until we can fix it. We often get the question, where's MariaDB installed and what version are we running? So MCO package, MariaDB status. Since the announcement this morning, it looks like there's going to be some better ways to get this information using PQL, so I'm really excited to try this out. So some of the lessons that we've learned along the way. Custom facts are irritating in a multiple OS environment. So make sure you start out using confined kernel. We found this the hard way when one of our Windows sysadmin was trying to set a patch window with a custom fact and ended up preventing all the Puppet runs on all the other servers when he made a small minor error. If you want to know more about the work that my colleague Andrew Ball has been doing, he's wrote a blog post. So there's the URL up there. Long-lived feature branches can often be difficult to merge back in. You can't avoid conflicts forever. You are going to have to deal with them eventually. Our initial lofty goal was to puppetize the entire OS and application as new applications were being deployed. But we quickly found in some cases this wasn't possible. The sysadmin hadn't received training yet. They weren't comfortable with it. Maybe we were piloting an application. We didn't quite know how to puppetize just yet. So we just created a base OS group for these servers so at least the OS would be managed while they're being while the other bits were being worked out. So we've had other culture problems that come along with this change. Not everybody's so excited about what we're doing as we are. Sorry. Linux sysadmins were brought into the project with different levels of enthusiasm, some surprising and not so surprising objections. Most objections were due to having to learn Git. I have to type so much just to change one file. As a Linux sysadmin, I don't understand why this is a problem, but apparently it was. The script we created actually helped, but we had a lot of conversations centering around why this increased workload was going to help, rather than just saying, yeah, you just got to do this. We tried to convince them it was a good idea. Windows people, even after training, are skeptical. One of our Windows sysadmin has been a really big advocate of the tool and has done the work to prove that the majority of what we're currently doing with GPOs can be done with Puppet. But we're still struggling to find an easy use case to convince them that it's better than GPOs. Some of the objections center around it being a Linux-centric tool, and this lack of specific Windows documentation, though this has definitely gotten better in the last year. Where we found a benefit over GPO is the ability to check if the change has been applied. With GPOs, you would have to search through logs or manually check to see if your change has happened. This change information is easily found through the Puppet Enterprise console via node reports. There's also a benefit from having a common set of tools across all of our OSs, but it's difficult to see this benefit if you don't believe that there's a problem with the current existing silos. Apparently I don't have a mouse. Hey, that's great. We're gonna go back. Okay, cool. Database admins, we have a large team of Oracle database admins, but they also do SQL, Postgres, and stuff like that. They were really, really eager to start using this tool. They've started writing classes and modules to distribute the scripts that they were manually SFTPing onto all these servers. These scripts are used to manage their Oracle middleware and database applications. When they started coming into the project, we discovered that their concept of development environment was quite different than what ours was. We often treated development as somewhere like, hey, let's try this out, see what if it works. And when in reality, we shouldn't. A problem in the environment could prevent the developers and application owners from making their deadlines and affecting the business of the university. We convinced them to try our workflow, and then we would find a better way to accommodate their needs, and we would switch to their model. So to start off with, they would do what we were doing. Looking back, we should have included them in the architecture discussions from the very beginning, and we should stop playing in development. So to get around this problem, we built masterless Puppet vagrant boxes. So I'm using Packer to build a rel box, and then Librarian Puppet to put all the appropriate modules on there so we can build it, do our code development and workflow, and then once we're confident it works in this little sandbox environment, it can be pushed to dev. This, if we'd done this sooner, probably would help with some of the fear of breaking things as well. We have a big, fearful environment. I don't know why. It's not like our people are really scary. Another objections we had was from our service owners. Even after we explained to them, yes, Puppet is awesome, it's gonna make everything better, they were not happy that we were gonna have to take more time to deploy a service. We actually went to an enterprise architect council meeting and discussed this change. And other developers who'd already experienced the Puppetization of their application became advocates for us. They were very, very vocal about how much better the service they were getting after the application had been Puppetized. So we found that even if we communicate to our service owners until we're blue in the face, having other people from other groups tell us that the change was good was a better way of convincing them. So we need advocates from other groups. So are we actually getting any better? Okay, that's weird. I don't have the right slide. Huh. That worked well, didn't it? I get notes or slides. I don't get both at this point. Yeah, I'm gonna need some help, sorry. There's my mouse. Let's try this. Huh, that looks like I solved it. Yay, me tech. All right, cool. I don't know, you really don't need the slides. They're just words, right? I mean, so is any of this actually helping us, or was it just a giant work project? Did we solve our original problem? We actually ended up solving a couple other problems that we didn't even know we were gonna have when we started this. Last year, we received notice that due to the number of payment transactions that were being done on campus, we would have 1 year to become PCI DSS compliant. And to do this, it's not really hard. You just have to follow some security standards. They're not really hard standards to achieve, but because the servers and the systems have been built slightly different over all the years, some of them would not meet the standards. We decided the quickest way to bring everything under compliance was to use the Puppet code that would be initially written as the proof of concept and extend this code for the Debian and Solaris servers. Only a small amount of refactoring was required, and the bonus was we knew they were going to remain compliant. The real win also come from a final meeting of the project. We discovered a number of applications that had not been initially identified as being in scope were being hosted on an ancient LAMP server. Due to the wide variety of all the apps on this server, coordination with the different groups on campus to make the changes required would have been a nightmare. With Puppet, we were able to quickly spin up 20 new VMs in less than a day for all the various applications, and each group could move and test their apps on their own schedule. Another win came when we had a recent ransomware incident in Canada at another university. This prompted management to make a decision that all sysadmins should use centrally controlled desktops. Well, Windows GPOs, that was already dealt with. They didn't really have to deal with anything. But if we wanted a Linux option, we needed a way to centrally manage our Linux Fedora desktops. So we started using Puppet to do this. Cool. I swear, this thing is going to drive me insane. Hey, now they match. So we've only puppetized a small portion of our systems right now, probably about half. We put the Puppet agent on a lot more. But as we continue down this path, our plan is to evaluate each service as we move the off-retired OSs and use Puppet to deploy the applications in OSs where possible, or only the OS where the application is too complicated to manage with Puppet code. We haven't been able to give our developers a one-click deploy yet, but we're working towards that. So some things that we want to do in the future, we'd like to do code review. Obviously, it'd be way better if we're using pull requests. So we can enable a DBA or a developer actually make the change to the code that they want right away. We didn't start off with this in the beginning because they were already complaining about having to use Git. I didn't want to make it harder for them. I'd like to use dynamic environments. This is obviously going to be a little easier with this new update, so I'm excited to try that out. They've changed how the branching works. We have a large number of role classes. I'm okay with that. I think I'm going to accept it as part of this, and we'll eventually just use folders to maybe classify them by service group. We're looking at vRealize as to automate the other parts of our workflow that need some help. So we haven't quite created this one-click deploy for these development environments yet, but we're working towards it. Hopefully vRealize will give us the dashboard that developers need. If not, maybe we'll find another product. I wasn't using it, so I'm good. That's not the problem. All right, so I've skipped a bit because the slideshow's being weird, which means I ended early. I'm sure everybody wants to hear me talk more. Okay, well, that's the slide I want anyway. Any questions, or is it beer time?
Is it ever not beer time?
Well, I did not drink before, so I'm really excited to drink now.
Question. I'll give you the
Did you need a mic for that question?
Well, my answer to your question is like, why not both? Did you run into anyone that had like fear of automation? Like, oh, you're going to automate me out of a job?
Not the fear of automating me out of the job, but the fear of new tools and new culture and new changes and trying new things and changing the workflow. I've always done it this way. Why do I need to change? GPO does everything I need to do. Why would I not continue to use it? I don't have to learn something new to use GPO. We did have a lot of fear, and it was from some surprising places. People were like, I'm in IT because I like to learn new things. I am surprised when people say, no, I don't want to learn. I don't understand that mentality. So it was hard for me to get my mind wrapped around that.
Are there some things that you found to be successful to drive that
fear?
change? Yeah.
The vagrant box to get people started would have been a better idea earlier on in the project. Training helps, definitely getting people in an on-site training where they could talk to somebody. Maybe more one-on-one. One thing that we found is getting more helpful is we started having bi-weekly or monthly architect meetings with everybody who's using Puppet and discussing some of the pain points that we're having right now. And let's see if the more experienced people or even the less experienced people in the room can help work out your problems. You're not kind of working in isolation. We have done a lot of pair programming, so we have like the Solaris guy sit next to the window guy, and they talk over what code should be done, and they work together quite well. So architect meetings to discuss pain points, code review, like paired programming helped a lot with that. And as far as fear, I don't know, how do you take fear out of somebody? Any questions? There's one here in the front. I can't see anybody, so if you talk to me later, I'll have no idea who you are. It's okay.
We're also from a university, and a lot of your slides spoke to me with all the, like, we're not at the scale of Netflix's and things, but, we support 200 different services.
Yeah.
So with that in mind, when you go to puppetize a new service, do you say we're going to do it from the OS all the way up to the application, or are there points where you're just like, I got the box for you, you can do your application at this point, or whatever, depending on the application?
It's really going to depend on the service group that we're working with. Some of them do want to do their own application install, and based on the application we're looking at, we may not be able to do the install via Puppet. My goal, personally, is to do Puppet as much as I possibly can if I have to work harder to get it there. But there's GUI installs, we can't do that. The developers I work with and the application administrators understand role-based access. So they understand they don't get root on the server. They get as much as they need to do their job, and a lot of times it involves us having to install the application for us. So in our environment, this is kind of working. If you're in an environment where you give them root on the box, this might be a little different. Does that answer your question? A little, maybe? Kind of? All right, any more? I think it's Barrow Clock. Cool, thanks for listening.
All right.